Myself, Vijay Shankar from ECE department, Chibrool Engineering College. Today, we are going to discuss about some more examples in convolution and the correlation with some properties. And these also we already discussed in the previous classes. What are the properties of autocorrelation function and cross correlation functions? The first property, the autocorrelation function. Autocorrelation is an even function of tau. The autocorrelation function is an even function of tau, that is Rx of tau is equal to Rx of minus tau. So it is not equal to Rx of tau and Rx of tau. If x of t is a real value, it has even symmetry. The formula for the definition of the autocorrelation function or xx of tau, or also you can write as simple R of tau. No need to write xx. R of tau is equal to the real functions x of t minus tau dt for the positive direction, and is a definition for the positive direction of the tau values, and x of t plus tau x of t for the negative direction of the tau, okay. Or for complex values, these are the real value. For complex value, the x of t, the x star of t minus tau dt, and Rxx of tau is equal to, this is also for the positive direction. Keep it as one of the signal is a complex conjugate signal to convert into the complex value, and Rxx of tau is equal to, for the negative values of the negative direction of the t values, the x of t plus tau x star of t dt, so the negative values of tau, and it is a positive direction of the tau values. Follow. That is Rxx of minus tau is equal to Rxx star whole star of the tau. How? I am taking a simple way to find out the equation of this one. Rxx of tau is equal to, what is the formula? By using the complex function Rx of t x star of t minus tau dt. Observe here, my dear students. Rx of tau, don't write it as xx every time. It is somewhat difficult to understand. R of tau is equal to autocorrelation function. Integral minus infinity x of t x star of t minus tau dt, and take the complex conjugate and change the value here. The complex conjugate means Rxx of tau whole star is equal to. See, already I kept it as a complex conjugate for the x of x star of t minus tau. Now it becomes of x of t minus tau and x star of t dt. Okay, here it is a minus only, my dear students. It is a minus t minus tau. All the changes, the x of t becomes of x star and x star of t minus tau becomes of x one. Okay. Therefore, change the negative values of the tau. The tau is equal to minus tau. Replace the tau is equal to minus tau. Minus infinite x star of t, x of t plus tau. The minus of minus tau becomes of t plus tau dt. See here, the x of t plus tau x star of tau is for the negative value, negative direction of the tau values is also equivalent to that of Rxx of tau. Okay, Rxx of tau. So see here, the Rxx star of minus tau is equal to Rxx of tau. But here it shows that the Rxx of minus tau is equal to Rxx of tau. Take the complex conjugate on both sides again. Conjugate and conjugate becomes of real. and the Rxx of star tau is equal to. So both are the equal. Okay, my dear students. This is one of the property. And the second property saying that the autocorrelation function is bounded by its value at the origin, is bounded at the value of origin. That is Rx of tau or Xx of tau is greater than or equal to Rxx of tau for any value of the tau. The largest value occurs at the tau is equal to 0 of autocorrelation function. Consider a finite energy signal x of t. Consider a finite energy signal of x of t. It's a combination of the two signals. It is x of t is equal to x of t plus x of t plus tau. X of t plus x of tau. Where is the largest value of the signal? Obviously, the magnitude, if I am taking any magnitude on both sides for the equation, the combination of the finite values, the magnitude is greater than or equal to 0. Greater than or equal to 0. You see, in the other side, we have another method, somewhat is an easy way. I'm taking the combination of the two signals, consider the functions x of t and x of t plus tau, and adding the two functions x of t plus x of t plus tau whole square is greater than or equal to 0. Expand the value here. Expand at greater than or equal to 0, x square plus a square plus b square plus or minus 2ab. You take the two functions, that's a plus or minus, and x square plus x square of t plus tau is greater than or equal to, here is a 0 is there, it goes to the right hand side, the plus becomes of minus and the minus becomes of plus. Again, it is a plus or minus 2x of t, x of t plus tau. Integrating on both sides, the integral minus infinite x square of t dt, and the second function integral minus infinite x of t plus tau whole square into dt is greater than or equal to. Again, here in the right hand side also, I'm taking the integral 2 into integral minus infinite x of t plus tau dt. In the left hand side, you can observe here both the functions are the energy signals only. The integral minus infinite x square of t and the tau also. X of t plus tau is greater than or equal to, or the greater than, magnitude of x of t plus tau, the squared magnitude is also the energy signal. So E plus E is greater than or equal to 2. And this function is the autocorrelation function, or Xx of tau. 2E is equal to 2 get cancelled, E is greater than or equal to Rxx of tau. What is the E? When you can substitute in this function, either any one of these function, tau is equal to 0, it becomes of x of t, x star of t. The squared magnitude of x of t at tau is equal to 0. Means Rxx of 0 is equal to E. Or R of 0 is greater than or equal to Rxx of tau. Okay. As that it is a Rx of tau. The autocorrelation function is bounded by its value at the origin. Bounded means it is in between the finite value only. Okay. That is Rx of 0 is greater than or equal to Rx of tau, or Rx of tau is less than or equal to Rx of 0. Okay. So the property 3 saying that is a property 3 only we are using in the second property. You see the value of autocorrelation function at tau is equal to 0 is equal to the energy of the signal. E is equal to Rxx of 0, that is equal to integral minus infinite the squared magnitude of x of t dt. The proof, the Rxx of tau is equal to, the formula is x of t, the definition x of t x star of t minus tau dt. At tau is equal to 0, Rxx of 0 is equal to x of t x star of t that is equal to integral minus infinite squared magnitude of x of t dt is E. Okay. The same is the energy signal. The autocorrelation for the power signal, take the limit t tends to infinite 1 by d, the integral minus t by the t by 2. Same equation you have to use as f energy. And tau is equal to 0. It becomes of limit t tends to infinite 1 by d, the integral minus t by the t by 2 squared magnitude of x of t dt is a power. P is equal. So Rxx of 0 is equal to energy signal and Rxx of 0 is equal to power signal. Otherwise, you can write as R of tau is equal to energy signal at the tau is equal to 0. At tau is equal to 0 or R of tau, the autocorrelation function at tau is equal to 0 is also equivalent to the power P, the power signal. The autocorrelation function at origin is equal to the average power of the signal, and autocorrelation function at origin is equal to the energy of the signal. Okay. In a similar way, for the periodic signals also, the Rxx of tau and Rxx star of minus tau are the complex conjugate to each other. R of tau is equal to R star of minus tau as a conjugate. Only the difference for the energy and the power signal is the limit t tends to infinite 1 by d, the integral minus infinite minus t by the t by 2. In autocorrelation only, not in the cross correlation, students. The x of t, x star of t minus tau dt. Okay. And Rxx star, if I am taking on both sides, the x of t becomes now the x star and x of t minus tau becomes of a complex to the real function. And change the tau as a minus tau here, x star of t and x of t plus tau dt. It is also equivalent to the R of tau. For negative direction and the positive direction is both are equal. So Rx of tau is equal to Rx of minus tau whole star. Okay. Then correlation is already we discussed about that one. Cross correlation. What is a cross correlation? Means it is a measure of similarity between one waveform and the time delayed version of the other waveform. Autocorrelation, it is a measure of similarity between one waveform and time delayed version of the same. Both are, it is a correlation only. Only difference is, it is autocorrelation is 1 and 2, cross correlation is 1, 1. 1 and 2 and 1, 1. The two functions, f1 of t and f2 of t. One is a complex function we can take, and here also the f1 of t and f1 of both the similar functions only. Cross correlation and autocorrelation, the difference is, the definition is it is a measure of similarity between one waveform and time delayed version of the other. If there is any time delayed version, it is a orthogonality function. So both are equal orthogonality function will get. Applications of the correlation, it is used to determine of the signal that are contaminated with the noise. So similarity, if any signal is contaminated with the noise, we can comparing the two signals, whether it is a simple similarities are there or not when it can transmitted after the transmitted, and at the receiver side, we are comparing the two functions. Okay. And cross correlation of energy signals. What is the cross correlation of energy signals? R1 to f1 of t and f2 star of t minus tau dt. R12 of tau, for the negative values, the direction is a positive and direction is a negative here. Okay, my dear students. And 2-1 of tau, when I'm interchanging the functions, 2-1 of tau is integral minus infinite f2 of t, f1 star of t minus tau dt, and 2-1. But even if it is a interchanging, it is not equal, it is a minus of the R12 of tau is not equal to R21 of tau. The negative direction is difference here, the tau value. are one to, unlike the convolution, autocorrelation function is not commutative. R12 of tau is equal to R21 of minus tau only. And the R12 of tau is not equal to R21 of tau. Okay, but the negative values of tau only after the interchanging is both are equal. Got it, my students? The difference between here, the convolution and the correlation. See, the convolution, the correlation is relation is one signal is a normal signal and the another signal is a folded function of the another signal. Then there is a relation we'll get for the correlation and the convolution. So actually the two signals, the minus infinite, if any signals of f1 of t and f2 of t, the two signals, the convolution function is a f1 of tau, f2 of t minus tau beta. But cross correlation f1 of t and the signals f2 of t is a cross correlation, my students. Cross correlation, and this one is a convolution. Okay, what is the formula with the definition of correlation? Minus infinite. The two signals is the same, f1 of t, and delayed version of the second signal, f1 of t minus tau dt. These are the two definitions for the correlation and the convolution. How it is converted, the correlation and the convolution is both are related. See, the t minus tau becomes of, assume it is a p value, and the t is equal to p plus tau. So either constant value is a tau and it is a variable is a t and the p value. Now I am assume changing that the t d tau is equal to d tau is equal to in terms of the dt. So dt is equal to d tau, not the dt is equal to the minus dt is equal to minus d tau is equal to d sub p. And the equation becomes of integral minus infinite f1 of tau is equal to t minus p. T minus p, the tau is equal to, and f2 of t minus tau is becomes of the p value here, the p dt is becomes d tau is equal to minus d suffix p. Okay, and when I am changing this a minus here is a plus and the minus, even if it is a t values, tau value is equal to minus infinite, the p value is plus infinite, and the tau value is equal to infinite, the p value is the minus infinite. So minus infinite, the infinite becomes of plus infinite, the minus infinite, f1 of t minus p and f2 of p. Now it becomes of the dp. Okay. So dummy variable, now you can observe the dummy variable here, the t minus tau and the f2 of tau and dp values. It becomes of the both the functions, one is not equal here, f1 of t and the f2 of t minus tau dt. And see here the f1 of tp minus tau and the f2 of t p and the dp. Now even if it is not, these both are equal. Okay, changing of the functions in terms of the tau and the dp. Now the t, substitute the t value as a dp instead of p value is a t and this is a t. And now you can observe here the tau, let us take this is a t, the tau minus t, and here the f2 of t, let us say one signal is a normal signal. Another signal you can observe here the f2 t minus tau, here we got it's a tau minus t, and I'm changing the dummy variable as a t, and the t is becomes of the tau here. Okay. If the tau minus t means the f1 of take the minus as a common, the t minus tau, then only it is the both are equal. So the functions when it is both are equal means one f1 of t with the convolution of f2, the second signal. Okay, the second signal becomes of minus of t. One signal is a normal signal, another signal is a folded function of convolution, then it is equal to that of correlation function. Understood, my students? So f1 of t and the correlation convolution of f2 of t is f1 of tau, f2 of t minus tau d tau. And cross correlation of the correlation is f1 of t, f2 star of t minus tau d. So t is a dummy variable here, and tau is a dummy variable. Convolution is a function of physical time t. It obeys the commutative law. The function of tau, it does not obey the commutative law. And r, when it is r12 of tau is not equal to 1 of tau, it is used to evaluate the response of the system for arbitrary signal f1 of t with the convolution of f2 of t is equal to, the frequency is a product. It is used to eliminate the noise from the signals, the correlation. It is used to evaluate the response of the system for arbitrary function, arbitrary input, and it is used to eliminate the noise from the signals, correlation function. And some more properties of cross correlation. Cross correlation, see already we tau is equal to 0, it becomes of energy signal, and tau is equal to 0, it becomes of power signal. But here, when the tau is equal to 0, it is not equal to the power signal and the energy signal, because it is the two signals of the different signals. Two signals are the different signals, my students. The second property saying, the first property, there is a Fourier transformation relation between of the correlation function. The Fourier transformation of R1 of tau is equal to x1 of f and the x2 star of f. The Fourier transformation. Now only we say that the correlation function and the convolution function relation. The correlation of the two signals, R1, 2 of tau is equal to, let you can take the signal is x1 of t, and I'm taking the convolution x2 of minus t. x2 of minus t. Now I can apply the Fourier transformation on both sides. The Fourier transformation of the R1, 2 of tau is equal to, is a Fourier transformation of the two signals, convolution of the two signals, x2 of minus t. So you know, the time, convolution in time, the frequency is a product. First signal x1 of omega, and second signal is not the x2 of t, it is x2 of minus t. It becomes of x2 star of omega conjugated. Okay, time reversal property. Using the time reversal property, we get x2 star of omega. Complex conjugator for the negative values of t values, any signal, you can apply the Fourier transformation, it becomes of a complex conjugate. Okay, now see the formula here, the x1 of f, the integral minus infinite to infinite, the Fourier transformation definition, x1 of t e power minus j omega t dt. Omega, now I wrote it here 2 pi f, and x2 of t, the integral minus infinite to infinite e power minus j 2 pi f into t. and x2 of t is equal to x2 of t minus tau e power minus j omega 2 pi f into t, as of I am taking as a inverse Fourier transformation relation. You can substitute here x2 of t minus tau e power minus j omega t, and then I'm multiplying this function as the total function with the e power j 2 pi f into t d tau function. Apply the conjugate on both sides. It becomes of x2 star of f and integral minus infinite to infinite x2 star of t minus tau. The minus becomes is a plus, and plus is becomes a minus. Plus is becomes of the minus. And now the multiplying the equation 1, we get x1 of f and x2 star of f. So x1 of f and the x2 star of f, we can both are multiplied. See, within this there is a function we have with the dt, the x1 of t and x2 star of t minus tau, and with this dt r12 of tau, and one exponential function e power minus j 2 pi f into tau d tau. Replace this total function as r12 of tau. It is a Fourier transformation only. The Fourier transformation function r12 of tau is equal to x1 of f and the x2 star of f. Got it, my students? And simply changing that is x2 of f as the x2 star of f, complex conjugate. So keeping the t is equal to t minus tau. So the whatever here we did is t is equal to t minus tau. The t minus tau f at place, and dt is equal to minus d tau. Here the minus d tau. Understood? So dt by d is a minus tau, and t is equal to t minus tau. The t values is from the minus infinite, and the t is equal to minus infinite. Both the functions from minus infinite to infinite, it becomes of the plus infinite to minus infinite. The negative value changes to the positive value, and again change the limitations from minus to the plus. Okay, so x2 of t minus tau e power minus, and then this function is now multiplied with the after complex conjugate with x1 of f. It becomes the Fourier transformation relation. Otherwise, you no need to do all these things. Simple, we can take r12 of tau is equal to, we know the relation of the correlation function, the cross correlation function with the convolution x1 of t and the star convolution of x2 of minus t. Apply the Fourier transformation on both sides, we get the same thing. The Fourier transformation of r12 of tau is becomes of one signal is a normal signal x1 of t, x1 of f, and x2 of f with the complex conjugate, because it is a folded function, the second function. Okay. And the second property saying the cross correlation function is a 0 for the origin, tau is equal to 0, r12 of tau is equal to r12 of 0, that is a 0. Why it is a 0? It is orthogonal function. Autocorrelation function becomes energy signal and the power signal. But in the cross correlation, when the tau is equal to 0, you can keep for any power signal or the energy signals. For power signal, you can see now the r12 of tau is equal to 0. Limit t tends to infinite 1 by 2t. You can take the 1 by t, it is a t minus t by to the t by t. x1 of t and x2 star of t dt is a function of the correlation, the periodic function. And cross correlation, third property is saying r12 of tau is equal to r21 star of minus tau minus 1. It's also already for energy signals and the power signals we did. r12 of tau limit t tends to infinite, and r21 of tau change of first signal as a 2 and the second signal is a 1. Giving that it is a tau is equal to minus tau, and complex conjugate you can take on both sides, 2 1 star, it becomes of R12 of tau. Okay. And cross correlation does not satisfy the commutative property because R12 of tau is not equal to 2 1 of tau. But from this only we can say 1 2 of tau is equal to the R21 star of minus tau means definitely it is not equal. The commutative property is not satisfied. Got it? Coming to the problems of the cross correlation, determine the cross correlation of function of Rx of tau of the two signals given, G1t and the G2 of t, the two signals. How to find out the cross correlation Rxy of tau. Rxy of tau. The two signals are R12 of tau because it is the first signal and the second signal. Defined by the G1t of is a cos 2 pi f1 of t plus theta 1 with the range of 0 to t. And the second signal is a cos 2 pi f into t plus theta t in the range of 0 to t. How does the vary the frequency difference f1 minus f2 affect this cross correlation function? According to the definition of cross correlation R12 of tau are x1 of t and x2 star of t minus tau dt. X1 now here it is a G1, X2 is the second signal, the G2 star of t minus tau. G1 of t as a into cos 2 pi f1 of t plus theta 1. And the second signal instead of the t that is becomes of t minus lambda. If I am taking the t minus lambda as a variable here, the tau, I take it is a lambda here because they're asking it is Rxy of lambda or R12 of lambda. Change here also the lambda one. Then only it is a correct. It is a lambda. Got it, my students? Here, this is also the lambda one. If it is a tau means definitely this is also the tau. Okay. So the t is becomes of t minus tau, t minus not the tau, t minus lambda. The second equation, wherever the t is there, you can replace that as a t minus lambda. So a into cos 2 pi f2 into t minus lambda plus theta 2 into d. Okay. What is the range here? The 0 to t. In the 0 to t only. 0 to t, a cos 2 pi f1 into t theta 1, a cos, expand this function, cos 2 pi f2 into t minus 2 pi f2 lambda plus theta t dt. We know the cos a minus b, since the cos a minus b plus cos a plus b is equal to cos a minus b plus cos a plus b is equal to 2 cos a cos b. Following my students, a minus b cos a minus b means cos a cos b plus sin a sin b. Cos a minus b is a cos a cos b minus sin a sin b. So sin cancels cancel and 2 cos a cos b will get. Using this relation, the trigonometric relation, divide with the 2 I taken here because it is equal to that of 2 cos a cos b. What is the a function here? 2 pi f1 into t d theta 1, and b is 2 pi f2 t minus total this function. Okay. And before that, there is a magnitude of a into a is there, a square, and I'm dividing the 2 because to get it is a 2 cos a cos b. If the 2 and the denominator can take the 2. Cos a plus b, first cos a minus b. Cos a 2 pi f1 of t into theta 1 minus b is this total function. What is this 2 pi f 2t? It is a plus here, there is a minus, and minus here, there is a plus becomes, and plus is becomes a minus. So cos a minus b, the first function, plus cos a plus b. What is the a here? Cos 2 pi f1 of t plus theta 1, and plus b 2 pi of 2t minus 2 pi of 2 lambda plus theta. Okay. we got the two functions, a square by 2 and integral 0 to t. Integral 0 to t, the first term is a cos function. Integral of cos is the sine. Sine total function by the 2 pi here. Only we can take as with respect to we are applying dt, the t functions only. What is the t function? Coefficients 2 pi f1 and the minus 2 pi f2. The remaining all it is a constants, because the integral we are applying with respect to the dt. That only can write as in the denominator 2 pi f1 minus f2. For theta 1, theta 2 and 2 pi f2 lambda, there is no any t there. To write it is in the denominator. And second function, see, it is also cos function. Integral of cos is a sine. Here also you can take only the t function. What is the t? 2 pi f1 is a t coefficient, 2 pi f1, and the second one is a 2 pi f2 into t, that is a 2 pi f2 into t. So take only the coefficients of the t, the 2 pi f1, 2 pi f1, 2 pi into f1 plus f2. So for the first term and the second term, upper limit and the lower limit is the t and the 0 and the t and the 0. Substitute that t and the 0 here is equal to a square by 2 sine the total function we have here. In that the t, the small t only change, that is a capital T. Sine 2 pi, here the two functions is there, the 2 pi f1 minus f2. Small t becomes the t and remaining is a constant theta 1 minus theta 2 plus 2 pi f2 into lambda, minus for the second function, for the second lower limit is a 0, where you can keep the 0 at t only. The t two t functions is becomes a 0. The remaining is a theta 1 minus theta 2 2 pi f2 into lambda, and denominator is the same. Now coming to the second term here, here also the small t replaced with the capital T, sine of 2 pi f1 plus f2 into capital T, theta 1 plus theta 2 minus 2 pi f2 into lambda, and second function, if the t is equal to 0, both the t2 terms is a 0, and we have only the theta 1 minus 2 pi f2 into lambda. Denominator is the same. Okay. So with this you can find out the R12 of tau for the given function. Okay. One of the example. Similarly, take another example as by using the graphical representation as of related to the correlation function, convolution only. Find the correlation function, correlation between the triangular gate pulse as shown in the figure. Triangular and the gate. Triangular and the gate. One signal is given the triangular signal, another signal is a gate function. Triangular is from -1 to 1, and the gate function is also from -1 to 1 only. Both the magnitude is a 1. But the first signal is a triangular signal, then the second signal is a gate signal. Okay. First of all, if I am taking the x1 of t, the triangular signal with the quadrants of -1 to 0 and the 1 and the 0 to find out the slope equation. To find the slope equation, here the point on the x-axis, what is the y? The 0. The point on the x-axis, what is the 0? Y 0. The point on the y-axis, the x value is a 0, 0 and 1. These are the three quadrants we have. At -1, 1, and the magnitude of 1 in the y-axis. To find the slope equation, I am taking here the x1 and y1 as a -1 and the 0, and x2 and y2 is a 0 and 1. The straight line equation y is equal to mx plus c. M is nothing but the slope. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. We already know, my dear student, this is the equation we learn in the first year itself only, or in the intermediate level. Now, what is the y1? Y1 is equal to 0. And what is a y? Because it's a triangular signal, the signal is x1 of t. So x1 of t minus 0. y2 minus y1 by x2 minus x1. y2 is a 1, x2, y1 is a 0. So 1 minus 0 divided by 0 minus of minus 1 is a 1. It becomes a 1 only. Slope is 1. And the x is the t, because the variables in the x-axis is the t only. T minus x1. x1 is a minus 1, minus of minus 1 is a plus 1. So x1 of t is equal to y2 is a 1 minus, and the denominator is a x2 minus of minus 1, the t plus 1. So x1 of t is equal to t plus 1 in the range of minus 1 to the 0. Minus 1 to the 0 only, my dear students. But I have to find that is a 1 and the 0. 1 and the 0, it definitely becomes of 1 minus t on 1 and 0. Okay, the reverse operation. The 0 to 1, the 0 to 1, the range is a 1 minus t. If I am taking the x1, y1 as a 1 and 0, and x2 is 0 and 1, the two signals, you can find out the slope here. Okay, I will explain this. So x1, y1 is equal to 1 and the 0, x2, y2 is a 0 and 1. Now what is the value here? y1 minus y2, y1 is the same, x1 of t minus y1 is equal to 0 is equal to y2 minus y1, 1 minus y1. y2 minus y1 is a 0 by the x2 minus x1 is a minus value. x2 is a 0, x1 is a minus 1. And x value is a t minus x1 is a 1. Okay, so x1 of t is equal to, it becomes of minus of t minus 1. So 1 minus t. So x1 of t is equal to 1 minus t with a range of 0 to 1. In the range of 0 to 1. If this is the slope, my slope means like here. The second slope, b it is. And the first slope is a. Okay, this one is for a slope equation, and this is the equation for the slope b. Assuming the minus 1 and the 0 is x1 and y1, and the x2, y2 is the 0 and 1. And for this slope, x1, y1 is 1 and the 0, x2, y2 is in the y-axis 0 and 1. We got the two equations in the ranges of minus 1 to the 0 and the 0 to 1. Okay, my dear students. For the second signal, a mathematical expression we got from the triangular wave, and the second signal is a gated signal. x2 of t is equal to 1. x2 of t is equal to 1 in the range of minus 1 t greater than or equal to 1, in between of minus 1 and 1. And x2 of t minus tau is equal to 1. The t is becomes of t minus tau. So minus 1 less than or equal to t minus tau less than or equal to tau. And bring the tau into the left hand side, the tau minus 1 because it's a minus. Go for the right hand side, the minus becomes it's a plus, less than or equal to tau plus 1. Now the range of x2 of t minus tau is equal to 1. The t values is minus tau minus 1 to the tau plus 1. So take the cross correlation function equation by giving the graphical representation of the two signals. One is a triangular wave and the other one is a gated wave. We got the mathematical expressions with the ranges of minus 1, 0 and 0 and 1, and the minus 1 to 1 becomes of tau minus 1 and the tau plus 1. Using the definition of cross correlation, integral minus infinite to infinite x1 of t, x2 of t minus tau dt. The case 1, the tau is less than the minus 2. Tau is less than the minus 2. There is no overlapping between x1 of t and the x2 of t. There is no any overlapping between x1 of t and x2 of t. So triangular wave and the gated wave is not overlapping at this. And the tau is less than the minus 1. And tau is less than the minus 1. Here see. Less than the minus 1 means all it is a negative value. So now it shifted towards the minus 2 to the 0 value. Minus 2 to the 0. Less than the minus 1 means let us assume here in this range the tau is equal to minus 1, my students. The tau is greater than, less than or equal to minus 1, all the less than values. So I am taking the equal to minus 1 means, so minus 1 less than or equal to t, less than or equal to minus 1 plus 1. Now it becomes of minus 2 less than or equal to t, less than or equal to 0. So see that I'm taking the gated function is from the minus 2 to the 0. Minus 2 to the 0. In this condition, the less than the minus 2 means we can take the minus 2 minus 1 is a minus 3, minus 2 plus 1 is a minus 1. So up to minus 3 to 1 only it is there, but there is no any overlapping, it becomes of the 0. So R12 of tau is equal to 0 because there is no any overlapping. Now the tau I am assuming the minus 1. So previously the tau is equal to minus 2, no overlap. No overlap. Now the range is from minus 2 to 0. There is a overlapping occurs from the minus 1 to the 0. Minus 1 to the 0. So in the minus 1 to the 0, it becomes of R12 of tau is 1 by 2 plus 1. In between of minus 1 to 1 only, the slope equation you can write as minus 1 to 0. You see here, minus 1 to 0. Minus 1 to the 0 value, it becomes of 1 by 2 into 1 into 1, that is becomes of 0.5. And in this equation, totally the R12 of tau, R12 of tau is becomes of 1 by 2 the plus 1. 1 by 2 the plus 1, or this becomes of 3 by 2. Then the case 3, the next value, shifting towards the right side, minus 2 becomes of minus 1, the tau is equal to minus 1 minus 2, now it becomes of the 0. The 0 means minus 1 to less than or equal to t, less than or equal to 1, minus 1 to 1. So fully it is a overlap here. Minus 1 to 1, it is a fully overlapped. Fully overlapped, it is a minus 1 to 1. It becomes of R12 of tau is equal to R12 of tau is equal to 1 by 2 into 1 and into 1, that is becomes of plus 1. And then it's a case 4, still it is a moving towards the right side. The tau is equal to 1. Tau is equal to 1 means 0 less than or equal to t, less than or equal to tau plus 1. Is a 0, 1 means a 2. So it's a range, it changes of 0 to 2 towards the right side. 0 to 2. And now the overlapping occurs from the 0 to 1 only. The 0 to 1. In this slope, we can substitute the value is a t. In the range of the t values. 1 plus the t. 0 to 1 the slope. 0 to 1 the slope is a 1 minus the t. 1 minus the t. Still it is moved towards the right side, that the tau is equal to 2. Tau is equal to 2. 2 minus 1 is a 1. 1 less than or equal to t, less than or equal to 2 plus 1, 3. So now there is no any overlapping occurs here. So it becomes of the 0. And it starts at tau is minus 2, no overlapping, it is a 0. And tau is equal to 2. no overlapping, it is a value is a 0. We have only the values in between of -2 and the 2, that is -1 and the 0 and 1 on. Following, my dear students. So now there is a overlapping occurs from -1 to the 0. -1 to the 0 value. In this -1 to the 0, there is a overlapping occurs, but here there is a slope also. So you have to find out this total equation. And this overlapping occurs, and here also there is a slope is there from -1 to 1. The gated function is equal to 1 only, the magnitude, total magnitude only. Remaining function is a 0. So the value is a 1. When in the second condition, the tau is equal to 0. And there is another way, the slope in between here value, slowly it is a decreases. At 0, the value is a 1, and it is decreases up to the 1, so 0 to 1, and this range is -1 to 1, and this range is a 0 to 1. So 1 minus the t value here, the t is 1/2, and the 1 plus t, that is also the 1/2 we got. When you can find out the slope, okay, my dear students, so find out the slope because it's a overlapping occurs here, and you have to find out the slope here, the value, the overlapping occurs. Understood? The similar fashion, you can find out the cross correlation and the autocorrelation function, really similar to the convolution function. Got it? So next, you can see another example of the correlation function, if anything. So we'll explain another example. You can take find the average autocorrelation. Autocorrelation means R1, R of tau, or R6 of tau. So what is the autocorrelation function? Average autocorrelation function of the given sinusoidal function. So x1 of t is equal to a sine omega 1 into t plus pi, where omega is equal to 2 pi by the t, or omega 1. Let us take omega 1. Find the autocorrelation function for the given signal. Only the one signal, because so since I am taking the x1, it is also the x1 into x2 autocorrelation function. Autocorrelation. What is the formula for the autocorrelation? To find the definition, R of tau is equal to, because you are finding the average autocorrelation function. Average autocorrelation function means 1 by t, the integral minus t by to the t by 2, power signal, my dear students, t by 2, x of t, x star of t minus tau dt. So definition of autocorrelation function, power signal. Okay. And it is a limit t tends to infinite also, my dear students. So there is a t tends to infinite. T tends to infinite, 1 by t, the integral minus t by the t by 2, x of t, x star of t minus tau dt. So what is a given signal x1? So you can write as x1 and x1 star is equal to limit t tends to infinite, 1 by t. That I am not writing totally the t minus t by the t by 2 as a t integral. As a t x1. What is the x1? A into sine omega 1 into t plus 5. And for the x2, a into, not the second one, x2, x1 star, it is a into sine omega 1 into, what is the t here? The t is now the omega 1 only, my students. Omega 1 into t minus tau plus 5 into dt. What is a into a is a square. So limit t tends to infinite. I'm writing in the outside of the integral of a square by t and the integral t sine omega 1 into t plus 5 sine omega 1t plus 5 minus omega 1 tau. I expand this one dt. See, it is in the form of sine A sine B. 2 sine A sine B. I am taking the 2 in the denominator also. We already know sine A sine B. Cos A minus B minus cos A plus B. Cos A minus B. Since using that is a cos A minus B minus cos A plus B. It becomes of 2 cosine A sine B is equal to limit t tends to infinite a square by 2t. Why I got the 2t? I multiply and divide with the 2. The integral, the total function now it becomes of in terms of cos a minus b. A is omega 1t plus 5 minus this total b function minus 1 omega 1t minus 5 plus omega 1 tau minus cos a plus b. Cos of here the omega 1t plus 5 and here also omega 1t plus 5 becomes of 2 omega 1t plus 2 5 plus here it is a minus omega 1 tau dt. The total function into the dt. Okay, my dear students. See, omega 1t minus omega 1t plus omega 5 and minus omega 5 is cancelled. The next it becomes of r of tau is equal to limit t tends to infinite 1, not the 1 there, it is a square by 2t and integral of now I am writing this one minus t bar to the t by 2 cos all it is to get cancelled omega 1 tau dt, the first integral, plus for the second integral minus t bar to the t by 2 cos 2 omega 1t plus 2 theta phi 1 2 5 minus omega 1 tau dt. Okay, second integral. That is equal to limit t tends to infinite a square by 2t and there is no any t functions, my dear students, here with respect to the t. The cos omega 1 tau is constant and 1 dt. 1 dt means that t with limits of t by to the t by minus t by 2 plus in a full cycle. See, they're saying that the omega is a 2 pi by t, 2 pi f. So in the full cycle, integral of cos is always a 0. You already know that one. In a full cycle, integral cos is always a 0. It becomes of 0, my dear students. So limit t tends to infinite a square by 2t and cos omega 1 tau and apply the upper limit is a t by 2. Lower limit means minus of minus t by 2. It becomes of the t. So here the t is there and the t by 2, the t by plus t by 2 is a 1. That is equal to, there is no any t terms now, no need of the limit apply here. So finally it becomes of a square by 2 cos omega 1 tau. This r of tau is equal. R of tau is equal to. Okay, a square by 2 cos omega 1 tau. Got it, my dear students? For the given signal, x1 of t is sine cos omega sine omega 1t plus 5 in the full cycle. The autocorrelation function we got a square by 2 cos omega 1 tau. Okay, so like that we can do any examples given for the signals, any signal, to find out the autocorrelation function. You see the remaining functions, my dear students. The energy density spectrum. This also we already discussed energy density spectrum and power density spectrum and having some properties. So no need again and again explaining this one. The comparison of energy density spectrum and the power density spectrum, and relation between autocorrelation and the spectral densities. Otherwise, I will explain in the tomorrow classes briefly, because it's already explained, and this is a material I have to send to you. So briefly, I will explain in the next class itself, my dear students. Okay. So any doubts? The tomorrow class you can close the fourth unit of both the sections, third year triple and the secondary EC students. Still any doubts, my dear students? Any doubts? Thank you.